Cool guys, so in today's video we're going to check out this question 1 from grade 12 June 2025, the paper 1. Cool. 1.1.1 is only a 2-mark question. It is equaling 0, which means it's a quadratic equation. There isn't much work for us to do here considering it's only 2 marks, which means the only thing we actually have to do is take an x out. We need to factorize. At this stage we have x in 2 places. X equals 0 for this first value here, and then x equals -4 for the second value over here. Cool. So with that, we have just earned 2 marks. So the next question 1.1.2, it is 2x squared minus a half equals 3x. The important thing here, 4 marks, but it says correct to 2 decimal places. The fact that it says correct to 2 decimal places means it is automatically our quadratic equation. We do not get any marks for writing the quadratic equation formula out, but what we do get a mark for is substituting the correct values in to the B, the A, and the C throughout. What we first have to do is we have to manipulate this guy to get it into standard form. So what that means is I'm going to take that 3x over to the left side. So 2x squared minus 3x minus a half. So this equals 0 at this stage. Cool. So now that we have it in standard form with our x squared first, then our x value, and then our value without any x on it. This value over here, this 2, is our a value. This -3 is our b value, and this -1/2 is our c value. So with that, we can then go ahead and sub it into our quadratic equation. So what we're going to do is we're just going to plug this into our calculator, get our 2 values, one with a plus, one with a minus, and then round it off to 2 decimal places, and we will have our marks. Cool. So while I was typing in the calculator, I saw that I didn't put my negative here for the -1/2. So I just need to plug that in there. Cool. So the first value we have is x equals 1.65. And the second value of x equals minus 0.15. Cool. So next question, we have question 1.1.3. It is an inequality. So it's 4 marks here. It is in standard form, and the pattern here has been take everything over to one side. So we're going to take this 2 over to that side where the 3x squared and the positive 5x live. So then we have that minus 2 is greater than or equal to 0. So at this stage, we just treat it like a quadratic equation, except we have an inequality sign here. We'll just treat that component of it at the end. So what we have to do is we have to split up our variables. The factors of 3 are 3 and 1, which means 3 will go into the 1 bracket here, and 1x will go into this bracket over here, which means that only 2 factors of 2 are 1 and 2. What we need to do is, the most common way of getting a value like this, if it's pretty big, is putting the big number with the small number. So usually we'd put the 2 with the 3 here and the 1 over here, and then this value over here would be pretty small. But if this guy's pretty big, it means with trial and error, we can just plug in our 2 over here and our 1 over here. And this approach, when a value is pretty big or bigger than this third term here, means we'll put the bigger number with the smaller number and the smaller number with the bigger number. At this stage, we just need to see what or how are we going to get a positive 5x. So 3x times 2 is, if we have a positive 2, it gives us a positive 6x. That's looking good for us. And then we have a minus 1 times an x, that is -1x. So if we were to refoil this, this would give us a positive 5x over here. The fact that it's -1 over here and positive 2 over here, those 2 times together give us a -2, and all these numbers will take care of themselves. At this stage, we are good to go. If we needed to double check, we could just foil it and solve from there, but at this stage, we do not have to. So the next stage for this guy is to get our critical values. So we're going to solve for this bracket. This guy becomes 1 over 3. Is the value of x, and this other critical value is x equals -2. So we have 2 CVs now, and we are going to treat them on a number line. So -2 is the smaller number, or the more negative number, going from negative to positive from left to right. 1 over 3 is chilling over here. But now we have to treat our inequality, or these critical values specifically. So at this stage, the fact that the crocodile is not eating the donut, that's how I treat the inequality. The crocodile is not eating the donut, therefore the donut is not inside its stomach. We are at this stage, this is an equal to sign, which means these little dots are colored in. And then once again, if the crocodile is not eating the donut is not inside its stomach, which means this would be where the crocodile's stomach would live if the actual inequality was eating the donut, but it is not, which means we are just going to the left and to the right. So at this stage, everywhere where this arrow lives is where our x needs to be. So x is therefore less than or equal to -2, or 1/3 is less than or equal to x, or x is greater than or equal to 1/3, because x can be any value less than -2 and any value greater than 1/3. Cool. So next question, we have question 1.1.4. This guy has an exponent, or x is in the exponent. So we have 2 to the 2x plus 2 to the x minus 6 equals 0. Most common way to deal with this is the k method. So what we're going to do is we're going to say k equals 2 to the x. So 2 to the 2x, if we were to split that, what we're left with is a k squared. And then at this stage, we have a plus k over here is what 2 to the x represents. And then minus 6 is there. And that equals 0. So we are just going to treat this like a normal quadratic, and then we're going to plug in this 2 to the x at the end. So we're going to split up our k into one bracket, k into the other bracket. This equals 0. And our factors of 6, we have 1 and 6, we have 2 and 3. So to get a positive 1, we're going to go with the 3 and the 2 option. We're going to go 3 here, we're going to go 2 here, we're going to go plus, we're going to go minus. And then we are going to solve for them. So k equals -3 or k equals 2. So at this stage, when we plug our 2 to the x back in, 2 to the x equals -3. This is unsolvable because it is not the same base, but the main component is that it is negative. If this is negative, this guy will always not be equal. And then k equals 2. When we plug our 2 to the x back in where k used to live, we have 2 to the x equals 2. And therefore, this guy had a 1 living up there. Therefore, x can and does equal 1. Great, so we have question 1.1.5 at the moment. Just like this previous method, which was exponential or had an exponent, or x in the exponent, this guy also has a common puzzle piece. By that I mean the x squared minus 2x is common here and over here. So if we make that equal k, then it'll be a lot easier to solve for this, because if we were to LCD this and get this x squared timesing all of these guys, we'd end up with x to the power 4, and that is not something we really deal with as much. So what we're trying to do is make this whole x squared minus 2x equal k. So when you plug it in, it becomes a lot neater, because then we have this, we have 2 over k, and that equals 0. And at this stage, now we can LCD it without having a whole messy array of x to the power 4 and all that. So we have k squared, timesing that guy up, times this guy up here, plus 3k. And then if we times this guy up, it doesn't have anything, plus 2 equals 0. So at this stage, we have k plus 2, and we have k plus 1 equals 0. These two guys will give us a positive 3 in the middle. And then at this stage, we're going to take it a step further. We're going to plug this x squared minus 2x back in after we've solved it. So k equals -2 or k equals -1. So we have those two options, and then we're going to plug each thing back in. X squared minus 2x, x squared minus 2x. I'm going to bring this -2 over, plus 2 equals 0. And then same thing here, x squared minus 2x plus 1 equals 0. So right now we have two different quadratic equations. Cool. So this guy's going to be a quadratic equation using the quadratic formula. But this guy we can solve for normally. This will be x minus 1, x minus 1. So then x's value equals 1 for both. And then this guy we're going to have to plug into our quadratic equation and then get our values, which I'm going to do now. And as I was working through this guy, I typed it in my calculator and I saw there was a math error for both, which means this is unsolvable. So this k cannot equal -2, and we have a restriction over here. Cool. And that is that question done. So at this stage, we have just earned quite a few marks. We only have 3 more questions left of this section. So question 1.1.6, we have the square root of x plus 5 minus x equals -1. So this last question, after an inequality, is a restriction. It's only 4 marks, and later on in prelims and finals, it becomes 5 marks. But at this stage, what we have to do is we have to take our x over to one side, and then we're going to have to square this to unhat this x plus 5. So I'll show you now. So we have the x plus 5 over here. I've already taken over the -1 plus x over here. And then at this stage, we're going to square this guy. And then what we do to one side, we have to do to the other side. Squaring a square root is going to drop the hat. So no more square root there. And then what we're going to do as we square this guy, -1 squared is 1. -1 times x is -x minus 2x using the SMS method. And then x times x is x squared. So at this stage, we have squared both and it becomes a lot easier to work with. So we're going to take everything over to one side. I'm going to rearrange this guy in a normal order. By that I mean the square and then the x and then the value without the x. So we got x squared minus 2x minus x, we have minus 3x. And then 1 minus 5, we have minus 4. So I'm just going to go ahead and solve for this. This equals 0. And then therefore x equals negative 4 and x equals positive 1. Well, these are the values in here. So therefore x equals 4 or x equals minus 1. So what we have to do is we have to plug both of these values back into the original equation to actually see the left-hand side equals the right-hand side, because there's always one of these guys that do not actually satisfy the equation and work. So I'm going to do that now. And the restriction is negative 1. Negative 1 does not work, and therefore this would be the fourth mark for this question. And now we're on question 1.2, which is a simultaneous equation. So what we have to do is we need to manipulate the 1, depending on whether we use substitution or elimination. We have to manipulate 1, get x by itself, plug it into the next one, and then get the values of that. The fact that it's 6 marks means there'll be 2 values for x and 2 values for y. So I'm going to start up here, a little bit smaller. X equals 5 minus 2y. So I've isolated for x, and now I'm going to plug that in to this other guy here. So what we have is we have 2y squared minus y, 5 minus 2y, minus 4, 5 minus 2y squared. So what we have to do, we have to FOIL this guy, we have to square this guy, and then we can start to simplify it. So we have 2y squared minus 5y plus 2y squared minus 4 is staying out here for now. So 5 times 5 is 25, minus 2y times 5 is minus 10y, minus 20y if we times it by 2, and then positive 4y squared. Awesome, equals 8. So at this stage, I can simplify this 2y squared and this 2y squared. So we have a 4y squared minus 5y, and then I'm going to distribute the negative 4 into all of these. Awesome, and that equals 8. This stage, I'm going to simplify things and take everything over to one side. So what we're going to do is we're going to see if there's any common value here. We can either do a quadratic equation, or we can try and divide it by a common 3, potentially that could work, or any value. So I'm going to check that on the calculator now. So minus 12 divided by 3, plus 75 divided by 3, and then 108 divided by 3. So that equals 0. We can divide everything by a negative. So I'm not going to do this in my head. I'm going to use the quadratic equation and get 2 values for y. At this stage, y equals 9 over 4, or y equals 4. So now that we have 2 values of y, I'm going to move over here. We're going to plug them back into one of these original equations. I'm going to do this guy over here, and then we can just solve for it. So x equals 5 minus 2 times 4, and x equals 5 minus 2 times 9 over 4. So we're just going to solve these, and then we have our 2 values for y, our 2 values for x, and we are done. So this guy equals minus 3, and this guy equals 1 over 2. Okay, awesome. So at this stage, we have solved for 1.2, the simultaneous equation, and we are on to the last question of this section. So it's very often a roots question, especially in the June paper. By prelims and finals, it's some sort of problem-solving harder question. But for a roots one, it says for which values of k will the roots of 6x squared plus 6 equal 4kx be real and equal. So 3 marks only, doesn't require too much work from us, provided we know what we're looking for. So the values of k, whenever we talk about roots, we are going to use our delta. Our delta is this guy. It is the thing underneath the square root in our quadratic equation. So b squared minus 4ac. So the fact that it is real and equal means we are just going to make these values, or delta, equal 0. If it was real and greater, then it would be a greater than sign. It would be greater than 0. If it was non-real, it would be less than 0. Delta would be less than 0. So these are the general setups as far as the inequalities, but whenever we see roots, we are dealing with the delta. So this guy isn't in standard form. So 6x squared plus 6 equals 4kx. So I'm going to take the 4kx over and set it up in our standard form. So here we have minus 4kx, and we have plus 6 equals 0. So here, this value is our a. This value, minus 4k, that's how we get k into this delta and solve for it. This minus 4k is our b value, and this positive 6 is our C value. So they're asking for real and equal. So we are going to make delta equal 0. But then when we plug it in, we're going to go minus 4k squared, because that is squared here by the delta, minus 4. Our A value is 6. So we plug that in over there. And our C value is 6 as well. And that equals 0. So minus 4k squared, the minus squared is positive. 4 squared is 16. And k becomes k squared. Minus 4, this is 6 times 6 is 36 times negative 4. And that gives us minus 144 equals 0. So we have plugged this into our delta, for which values of k will the roots of this guy be real and equal. So if we divide by 16, we have k squared minus 9 equals 0. Once we're here, what we have is dots. So we can either take the 9 over, square it both sides, leave it plus or minus, or we can open up here, k minus 3, k plus 3 equals 0. Then therefore, k equals 3 or k equals minus 3. Great job, guys. So that is everything for question 1 of the June 2025 paper. I hope this helped. Let me know if there are any questions in the comments below, and then I will see you in the next video.